for this lesson we're going to talk about the pendulum. This will be simple harmonic motion or periodic motion to do with the pendulum itself. Okay, so remembering simple harmonic motion is when a restoring force tries to bring an object back to the middle place, back to the equilibrium position. We already talked about the spring. Today we'll talk about the pendulum. So some key words on this which you'll know from before. The pendulum itself, amplitude, the height of the wave, the period, the frequency, equilibrium. These are words that you should be familiar with. So we did a virtual lab in the class. You find where the energy is the highest, the kinetic, where the potential energy is the highest, what will the speed be at the top, or force brings it to the center. You'll realize that at the very top, the potential energy is highest, storing the energy. The speed is 0. And if it comes down, falling, you'll realize that you have kinetic energy. So at the very bottom, it'll be the highest kinetic energy. And that is what we discovered in this lab. So any object, by the way, that swings with an angle of less than 15 degrees, this will also follow Hooke's law. Gravity is the restoring force in this case. Okay, so just to remind you, amplitude is the maximum displacement from the resting point. Period is a time for one cycle. Frequency is how many cycles it completes over a chosen time. So these two formulas will still be useful for us. Okay, if you wanted to find the period or the frequency, you can do using this rule. We did some examples together, but there was a point where we find that you might not know the frequency, but you do know the length of the string. So we can actually calculate this formula using the length of the string divided the string divided by gravity. Gravity is 9.8. So you should be able to rearrange this to find L, and I did that with you in class. If you wanted to find L, we'll take the formula 2 pi square root L over G. You can divide both sides by 2 pi to cancel this side, so you have this here. Then you cancel the square root to make it squared. And then what you can do is you can take the g to the other side and you can multiply by g. Essentially, you don't need to know about this part here. You just need to know the final formula. L equals g, t over 2 pi, and square that part. And you can rearrange to find g if you like. You can take this whole thing, this whole bracket, all the way to the left and divide it underneath the L. And that's an easy way to find g if you had to. Okay, you did a simulation here. We swung the bob and you found the period and you changed the mass and the length and you noted your results. You realize that when you change the length, this gets bigger. If you increase this, this gets bigger. Increasing this gets bigger. But when you change the mass, nothing happened. It was the same. The mass did not affect it. The pendulum did not depend on the mass, but it does depend on the length. That's what we found from our conclusion. And we check it using the formula. Okay, so that was helping us how to find it. There were some practice questions that we did. And one thing you do need to know is a simple pendulum versus a physical, a real pendulum. And the real pendulum is a bit different because not only do you have the length and the gravity, we have other factors like air resistance, friction, even the string itself has a mass. They will all affect this. Okay. And if you have resonance, this word here is when you use small force. If it's at the right frequency, it will make the amplitude of the vibration get bigger and bigger and bigger. This is called resonance.